Good morning. Before I start, I'd like to thank all of you for participating in this session and allow me to exchange ideas with you. As Peter just mentioned to you, he talked about the AI algorithm, and what I'm going to tell you is what kind of infrastructure we need to build to really promote the lower cost and higher quality of care in healthcare sectors. So in order to do that, what I'm going to do first is ask ourselves, what are the resources available at our hand? And is affordable, scalable? So first, we look at the history in the last 50 years. In the consumer markets, what we have witnessed in the last 50 years, following the Moore's Law, the price for the microprocessors, the computers, is dropping almost million-folds. And in terms of processing power, increased more than million-folds. Right? So you look at the 60s, a mainframe computer versus today's a microprocessor. The processing power is about 10 to the 7th power, more powerful than a mainframe computer, but it only costs you about $2 to produce. In 60, that was about $1 million. And second thing is, we have seen is now we are all connected because of the available global infrastructure for communications. Here we have a 3G. In other states, we have a 4G, 4G LTE, and looking to the future, 5G. Right? So that will really promote the connectivity among all of us and how we can share the data to really understand the implication of the data. And last piece is very important to us is now we are all very savvy in using technology. Otherwise, we just have a technology only for experts that will not really drive the direction in reducing the cost, improving the quality. So as a result, we have a completely new class of cyber-physical products. And the way we work, play, and communicate, think. So technology is a commodity, cheap, and ubiquitous. Right? What are the cyber-physical products? Here's an example. Probably you have heard a lot of time, smart cities, smart this and that, smart home, smart building. And what is really the driving force behind that smart things is this so-called the cyber-physical system for Internet of a Service in the wireless connected world. Right? So what is really the cyber-physical systems? So cyber-physical system consists of 3 major components. At the front end is so-called the edge. When we say edge, means interfacing with the physical world between the digital world and physical world. That's the edge. And in the core of the cyber-physical system is the brain, so-called the cloud. And in between the edge and cloud is connected by the backbone communications. So that's to make an analogy between this cyber-physical system and the human activity. So the edge can be considered as a human with a 5 sense. How we see, we hear, we can taste and smell and touch. And with a common sense. So how we use that 5 sense to promote the activity is by sending the signal. Say, for example, when I need to move forward the slide, what I need to do first is I need to look at which slide I'm at and sending a signal through my central nerve system, and I'm moving forward with this slide control. And that is a feedback system built into this cyber-physical systems. So the central nervous system is equivalent to all the communication we use today in your cell phones. And the cloud is basically our brain, right? So this is the system we have. So you can think about when we try to develop the newer generation of product to promote better health and lower cost, we can think about the human activity, how we can utilize those available resources developed over the years, and it's affordable, scalable to come up with the product. So when we look at the edge device, we ask ourselves, based on the projection by 2025, worldwide will have about 10 trillion sensors. right? So if you use those sensors every 10 seconds to generate the data, every day, how many data points you will have. This is what the world we are living in terms of available information to us. So at the same time, we say, we have a lot of data. What do we do with it? Fortunately, what we have seen is over the years, start with a mainframe computer, and today, in all the wearable devices, every person in your pockets, probably you own about 8 to 10 microprocessors. They are processing the data on your behalf to provide you with the informations. So that is what we are living in. And those data can help us to make certain decisions. So AI is not about artificial intelligence, it's about augmented intelligence. To augment with our perceptions and how we can make better decisions. So now let's move forward to the next stages. This is what happens in different business sectors, but in the health sectors, there are three major sets of data we have to look into. The first one is a typical traditional data created from the patient by the physicians. When we go to see a doctors, depends on the disease we have, we are asked to do different kind of diagnosis and data generated. At the same time, our gene sequence and so on will be generated. In addition to that is, because we are able to really leverage those consumer electronics, there are different set of data, which is non-invasive way of collecting the data to complement the data produced by the expert physicians. In addition to that, because our ability to use those sensors and microprocessors, we are able to collect the data from the living environments about the food, about the air quality, about the waters, everything we do. And those are the three major sectors of information critical to determine the health of the human conditions. And those solutions are readily available and affordable because we're really leveraging the consumer electronics products. So when we are able to collect so many data, so we ask, who care about the data? So this is the report by economists. Talk about the data is the new oil. Depends on how we extract the data, how we refine the data, and how we distribute the data. And once we are able to do that, we can monetize it. But one of the critical things is in the process of monetizing it, we have to make sure it will not pollute the society. Pollution, in this case, is about cybersecurity, about the privacy. I think it's the same thing we're living in the physical world, pollution produced by the oil. Right? So there is an equivalent competition between the physical world and the cyber world. So knowing there is an opportunity to create the new value from the data, so how do we reconstruct the infrastructure so that we can empower individual and physician and caregiver to deliver better quality of health care. So this is what I envision, a sustainable health service. We need to build the health system infrastructure leveraging consumer electronics because that has been developed over the years. And there are so many new products coming out, and the price is coming down every year. Like our smartphone every year, every other year, change to a new phone, and price is coming down. We continue to leverage that. The second thing is the available data, as I just mentioned to you, from the health sectors. Together, we can come up with a solution for the health system infrastructure. It has to enable two things in order to lower the cost and improve the quality. First one is the infrastructure need to be able to enable the new discovery. Without the discovery, the cost will not come down. Right? If there's a way to find what is the possible disease to do the preventive treatments, it will be lower cost than reactive medicines. So the second thing is the infrastructure need to enable medical operations. how the physician, caregiver, and person have easy access to the data, to the information, not information, the actionable intelligence, so we can act, be more efficient. So this is the requirement for such a system. The impact is to empower researcher and caregiver to continue innovate the health solutions. Think about the health solution now is predictive, is preventive, personalized, participatory. Everyone can participate. Health is not about patient and doctor. It's about all of us. We need to live in a healthy wellness lifestyle. And what is the technology can do for us is to empower us to do that. As a result, we don't need to worry about disparity. And that is the solution. We can leverage the data and consumer electronic technology. And as a result, reduce the operation costs, enable individuals engage in the healthy living style. Right? Engagement, now you can really think about how you use the consumer electronics in a way to gamify the process. Right? So those are the solutions we always think about. So the system, how we can develop as an engineer, now we can come up with a schematic of the system design. So on the left-hand side, this is the edge device. So think about, for the edge device, the artificial intelligence is about human-centric edge computing. What kind of computing resource need? It's human, it's not a patient now, right? To address individual needs. So you may have a different way to acquire the data, the sensors, and the sensor can collect the data about humans' cognitions, living environments, physiological condition, and the medical history. And here I use a human as a mobile sensor. What I mean is physician can provide the feedback into the system as well as our family members. They watch us. They know what happens over time. And remember the difference between such a system from the traditional automation control is at the instant you try to provide the feedback. And think about the health is about longitudinal data over time. So we need to have a way to collect the data and analyzing and doing the computation at the edge about the individual's needs. And if that require always go to the cloud and come back, it will be very costly. So that is the reason why we see in the last few years, edge computing become one of a very popular topic in terms of developing the solution, because this is a traditional way. You send the data to the cloud and doing all the AI and send back either through the physician and have the patient to act upon it. Or you go through this system every time you need to upload the data. That would be too costly. So you have to push the AI from the cloud towards edge. So how do we do that? So this is a typical way when we are moving from the server cloud to the edge. The first step is typical in the cloud and the server. The first step is doing the training like Peter just talked about. Then you can follow up with execution, inference. And in the edge devices, what is good at is because it cannot handle the large data sets. Right? So the training is emerging, but most of the time it's learning from the cloud, and you have a way to download that algorithm locally. It can do the execution, inference, as a way to assist individuals to make decisions. And that is an affordable way of improving the quality of care. But this is not easy. When you move those computation resources to the edge, especially when we try to address individual need, we are talking about mobile computings in your pockets, right? Your cell phone or your wearables. So the typical in the AI challenging is always on, and is real time as a very complex concurrence calculation and very compute intensive. It's going to consume a lot of battery energies. As a result, most likely your cell phone would only last for 10 minutes, not for whole days, right? So this is the constraint environment is because of when you do a lot of computation with your microprocessor, like in your phone, easily you can get up to 20 watts, like a light bulb. You can imagine it's inside your phone, you have a light bulb, it won't last too long. And in your cell phone, it has a very limited bandwidth, storage, unlike the server in the cloud. So those are the computation challenging in front of us. And in terms of computing resources, in order to develop the solution for mobile computing at the edge, still we're using the same technique, like a CPU, GPU. Those are the NVIDIA GPU, the graphic processing units. This is a central processing unit, the typical Intel's. And TPU is a TensorFlow processing unit developed by Google for the neural network. And digital signal processing and FPGA is getting very popular. This is so-called field programmable gate array. So on demand, it can be configured for the hardware so that it can be more efficient during the computations. And most of the time, when you look at the solution in hardware, it's a combination, various combination of those units putting together, and it become so-called SoC, system on a chip. So that can be affordable, but still very costly. And at the UCI, we are also looking into the possibility of using the low cost, probably for someone working in the electrical engineering, Raspberry Pi. It's a very cheap, right? $10 to $30 a processors, has a huge processing power. If you use a distributed way to send the data to different processors, you can achieve the same performance. And it can be a low cost for local computation needs. And you look into the future, as I mentioned, for the connectivity from the 3G to 4G, 4G LTE, and next one is a 5G. Probably you heard a lot about 5G, right? Especially our president talked about 5G being the national security. So what is the 5G? 5G will give you the data rate about 10 to 20 gigabit per second wirelessly, right? So that is the connectivity will be available to all of us. As a result, what we will have is now the cloud connected by all the base stations become distributed cloud. So the edge and cloud will converge into different locations. So this is each one is a base stations, and this is the antenna. This is the hardware for the network, but because of the way we are able to connect them in such a high speed, about 100 gigabit per second. So entire 5G network become a supercomputing resources at your fingertip. So now you can access from different point, use it as an edge device to support your needs for computation. So that is the reason why in the future, the edge computing will be also affordable to most of us. So that is it's coming. I think it's in the next few years, you will see a lot of activity happen in this area. So now you may ask is, okay, you talk a lot about the infrastructures. Any success, right? So here I'm going to illustrate to you is a few examples how some of the companies have developed the solution based on those consumer electronics. The first one is done by the Google using the smartphone as a way to do the extract the blood vessels, as a way to predict the diabetes or, or the heart disease. And this become very popular solution in India. What I was told, there is lacking of ophthalmologists. You don't have a specialist. So it's not really affordable. By using cell phone, the smartphone, with a camera, now you're able to dispatch the solution to the needed group patients. Right? So this is an example. The second one is the detection of prediabetes or diabetes using those wearable electronic like a Fitbit, like the Apple Watch, and so on, simply looking at the heartbeat variability and use that as a data to identify who is a high-risk group of having pre-diabetes, 10 years ahead of onset of the diabetes. And this is based on UCSF, a study of 1 million patients. So this is looking at the huge data set and try to look for the norm and how to do the statistical analysis, identifying which group is high risk. And this is just an example how we can really leverage the existing infrastructure of consumer electronic and leverage the big data to provide a solution for the patient. Think about what is the typical way we do pre-diabetes testing. A1C, you have to draw blood. It's invasive. Now this is you're wearing Apple Watch. And now I can tell you, say, you better see a doctor to draw blood, right? So this is the examples. So here I'm going to give you another example. This is developed by, I'm downloading.
Everyone responds differently to disease and treatment. At AI Cure, we're working to understand these differences. We believe our unique capacity to combine behavioral and biological responses will pioneer a brand new field in medicine, unlocking new therapies and benefiting all patients. We developed IMA, an interactive medical assistant that uses computer vision and neural networks to assist patients and ensure they receive treatment. By engaging with patients every day, IMA can see, hear, and understand how patients are responding. Subtle day-to-day differences that otherwise go undetected provide new ways of measuring and predicting clinical progress. We provide the healthcare industry access to a universe of behavioral data. This allows them to understand and predict which treatments are most effective. Researchers and clinicians are leveraging this powerful data lens to guide new therapies that are as unique as the patients they serve.
How are you doing today?
So this is one example is we are leveraging the longitudinal data to enforce the compliance of taking medicines and to understand the people's behaviors. I think it can observe the privacy issue because you are doing it at home, because we know the medicine compliance is a major task in everywhere, because most of the senior, they believe they are fine, they are not taking the drug, right? So this is one way can really help us to better understand your friend, your relative, your parents, or your kids, how they are taking care of themselves. So here, just some of the example of leveraging the resource available from the existing consumer infrastructure and develop the AI, push to the edge, and in the process of doing that, you don't worry about the privacy because all the data now is still belong to you. Thank you.